Hello and welcome back to this NPTEL course titled Quantitative Methods in Chemistry. This is week 4 and now we will be starting lecture 2 of this week. So far in this week we have already been introduced to the concepts of confidence level, significance level, and what we understand is that the confidence level is essentially a probability of finding the population mean around the sample mean. Similarly, we have the concept of significance level, which is a concept that tells us that how probable is a result being outside the confidence interval. Now, how do we define confidence interval? Confidence interval is the interval around which the sample mean is expected to lie with a certain probability. So, we also got introduced to the concepts of Z and T statistics, and we got to know that when we are having a very good estimate of the population standard deviation, then we can use the Z statistics. However, for small samples for which the standard deviation, population standard deviation is not accurately known, in those cases we can use the T statistics. And we also understood that when our number of readings for a sample is large, then the T statistics tends to the Z statistics. In other words, when n value increases, then the T statistics, the Z statistics. So, with this basis, now let us start discussing what we will be covering in this lecture 2. We will be talking about the null hypothesis and the alternate hypothesis, and we will see how Z and T statistics can be used to test the hypothesis in our hand, and we will also understand how the alternate hypothesis dictates which of the two tests, which is the two-tailed test or the one-tailed test, is to be applied. And as we progress, we will also understand how errors in hypothesis testing come about and what is the importance and significance of these errors in terms of the inferences that we make. Finally, we will get introduced to the concept of outliers, and we will utilize the Q tables for identifying the outliers in our data set. So, moving ahead, let us first describe what we understand by null hypothesis. Null hypothesis is a presumption which says that there is no statistical significance between two measurements being compared. In other words, any minor differences between the observed values is presumed to come due to random fluctuations and is not in real. And this presumption of null hypothesis is then tested using statistical tools such as the Z test and the T test, and we set a critical level of significance alpha beyond which the null hypothesis is presumed to be questionable and cannot be relied upon. And now let us move to the concept of the two-tailed test, which is a test which is most routinely utilized for comparing two data sets. So, let us understand this concept by taking two examples. The first example is that of a certain city in which the mean level of carbon dioxide is listed as 1200 plus minus 100 ppm, while after say a recent spell of rains, this value was found to be 1050 ppm. Now, the question that we have at our hand is, at 95% confidence level, can we say that the observed value of carbon dioxide levels after the range is indeed different from the commonly observed value of 1200 plus minus 100 ppm. Another question in the same line could be that of a buffalo milk sample, where we know that typically buffalo milk should contain about 6% of solid not fat, but this sample that we are dealing with contained 7 plus minus 0.2% solid not fat. Now, the question that we want to answer is that is the SNF content of this sample at our hand is different from the actual buffalo milk at 95% confidence level. So, I want you to take note of 2 points. One is that we test the hypothesis at a particular confidence level. In this case as well as in this case, this number is 95% confidence level. And another thing is that we are being asked only to tell whether the reading at hand is indeed different from an accurate value or a population mean value. So, in those cases our question is to only address whether these numbers are different or not. So, in such cases we will apply the two-tailed test, because a reading can be either low or it can be higher than the mean value of a certain population. And as we have already discussed that a randomly collected sample from a large population will follow a Gaussian profile, and the mean value will be the most probable value as well. So, as we move away from this mean value, the probability of occurrence of a certain reading reduces significantly. So, in nutshell, if we have to tell whether the values being compared are statistically different from accepted or known values, then we apply the two-tailed test. And for the two-tailed test at 95% confidence level, what we imply is obviously the significance level is 5%, which is nothing but 100 minus 95, or if we write it in terms of decimals, it is 0.05. But this 5% significance region is distributed evenly on the two tails of the Gaussian profile shown here. Now, when that happens, essentially we are talking about a z value of plus minus 1.96. So, the region that I am going to highlight now, this whole region which has been highlighted with the red lines is to be considered as the region of significance. So, any reading that lies in this region will be considered statistically significantly different from the mean value, which is shown at the peak of the Gaussian profile, and we state our results at a certain confidence level. So, 2 points to remember from this slide are that we are reporting our hypothesis testing at a certain confidence level, typically 95%, but it can be 99% or 99.9%, depending upon how accurately we wish to report our findings. And another important point to be noted is that a two-tailed test can be applied only when the question at hand is whether the readings being compared are different or not. Now, if we rephrase this question as to whether the readings are lower or higher, then in those cases we are concerned only with one of the two tails of the Gaussian profile. So, in those cases, if we want to tell whether a measurement is lower than the population standard deviation, population mean, in those cases we will be using the left tail of the Gaussian profile. However, if the question at hand, for example, in the question 2 highlighted here, the question at hand is whether the reading is higher, and when we are dealing with that, we are going to be concerned with only the right hand side of the Gaussian profile or the right tail of the Gaussian profile. So, all the significance region will be lying at one of the tails, and that is why this test is known as the one tailed test. And when we talk about one tailed test at 95% confidence level, we imply again the significance level of 5% being lying on only one side of the tail. So, for example, for the question number 2, where the buffalo milk sample is to be compared with a standard sample with 6% solid not fat, in this case we need to only tell whether at say 5% significance level the reading is different from the standard or not. So, our significance region is restricted to only one side, and that implies that we use a different z value, which is 1.64 in this case. Now, if the value to be compared is supposed to be higher than a population mean, then we use the z value of plus 1.64, and that becomes our critical z value. Similarly, if we are concerned with whether the reading is lower than the population mean, then we use a z critical value of minus 1.64, being concerned with only the left hand side of the tail. So, I hope with these examples it is clear which of the two tests are to be employed and how is what we will see now. So, before that I want to re-emphasize that our T tables already incorporate this point by giving us the significance levels for a two-tailed test and for a one-tailed test. And what you will see is that for a one-tailed test, the significance value is half that for a two-tailed test. Okay. So, coming to 95% confidence level, if we are applying the two-tailed test, then the z value was 1.96, while if the test being applied was only a one-tailed test, then the z value was different and it was 1.645. Now, let us see how z test can be applied for hypothesis testing. So, it has to be clearly understood that when the sample standard deviation is a good estimate of the population standard deviation, that is when the z test can be applied. And protocol for applying the z test is that we first state the null hypothesis, and null hypothesis is represented by H naught, and of course it presumes that the test mean and the population mean are statistically similar, and this is mathematically written as what I have indicated in the box. H naught is x bar, to indicate that it is a mean, is equal to mu naught. X bar is the sample mean and mu naught is the population mean. Now we calculate z value based on the data with available to us. So we do x bar minus mu naught and divide it by sigma by root n, where n is the number of readings in a data set. So when we do our z calculation this way, we can compare this calculated z value with a critical z value, which we have denoted as z critical, and based now comes the question that we need to address, whether it is only about x bar being not equal to mu naught. In those cases we will apply the two-tailed test and we will compare whether the z calculated value is either greater than the z critical or less than the z critical. However, if our alternate hypothesis, which is being denoted by HA, is whether the sample mean value is greater than the population mean, in those cases we can reject the null hypothesis only if the z calculated is greater than the z critical, and in that case we will be applying the one-tailed test. So the z value, z critical value has to be chosen appropriately, and we will be concerned only with the right tail of the Gaussian profile. If the alternate hypothesis is that the sample mean is less than the population mean, in those cases the null hypothesis is to be rejected if the z calculated is less than the z critical value at a certain confidence level, and again we will be using only one of the tails, which is the left tail, in this test. Okay. Now, under which conditions do we apply the t test? For hypothesis testing, the t test is to be applied when we do not have a good estimate of the population standard deviation, or in other words, the presumption that the sample standard deviation is similar to the population standard deviation cannot be considered true. In those cases, or whenever you are in doubt, you should apply the t test. So the protocol is very similar for the t test as well. We again come up with a null hypothesis which presumes that the compared values are statistically similar. Now these compared values are the sample mean and the population mean for us. So we state the H naught accordingly, and we test the veracity of this presumption by applying the t test. The formula also remains more or less similar. However, the only difference that comes now is that we are talking about the sample standard deviation S instead of the population standard deviation. Now, as previously, we will apply either the two-tailed test or the one-tailed test depending upon the hypothesis that we want to test. Now, let us take a real example to understand this concept in a greater detail. Suppose we are talking about 30 students, so our n value is 30, and these students have a mean weight of 27.7 kilograms, and the standard deviation for this sample is 5.2 kilograms, and there is an average weight which is a national average which is available to us from the previous studies, and this tells us that for this age group the weight of the student should have been 30.8 kgs. Now, under these circumstances, can we say that the observed mean is different from the national mean at 95% confidence level, or in part 2 at 99% confidence level? And we make a presumption in part A that the sample standard deviation S is same as the population standard deviation. In part B, we will see if we do not presume this, then what happens. So, in other words, for A, we will be applying the Z test, for B, we will be applying the T test. And now, let us apply the two-tailed test here, because we are only to address whether the readings are different or not. So, let us do this exercise. So, what we know from the obtained data is that the x bar value is 27.7 kilograms, while the mu naught value was supposed to be 30.8 kilograms. What we also know is that S is equal to 5.2 kilograms. So, with this data available and the presumption that S tends to sigma, it would be easy to figure out whether the x bar value of 27.7 is statistically different from the national average of 30.8 kilograms. So, let us do first is the null hypothesis, and this states that, or this presumes that, the x bar value is same as the mu naught value, and the veracity of this hypothesis is to be tested now. So, we will do in the second step the calculation of the z value for this data set. That will come out to be 27.7 minus 30.8 divided by root 30. Now, this comes out to be minus 3.1 divided by 5.2 by 5.48, or finally this turns out to be minus 3.1 by 0.949. In other words, the final z calculated value turns out to be minus 3.26. Now, what we need to do is to calculate this z value, in the third step we will calculate this z value, compare this z value with a z critical. So, z calculated was minus 3.26 and z critical at 95% confidence level for a two-tailed test is to be checked, and this should be equal to plus minus 1.96. So, z calculated is greater than the negative value of the z critical, then we say that we need to reject H naught, the null hypothesis, at 95% confidence level. Okay. Now, this was the part 1 of the question. In the second part, we wanted to ask if at 99% confidence level also we can say that. So, we just need to compare the calculated z value, which is not going to change, with a z critical value at 99% confidence level, which now will be different, and z critical value now is 2.576. You can look at the T table to check that this number being reported for the z critical value is correct or not, because you need to report this number and then make a comparison, and when we compare we still find the third step still is that the z calculated value is greater than the z critical value, and which implies that the null hypothesis is to be rejected even at 99% confidence level. So, we can report our conclusions at 99% confidence level that the mean value of the weight of these 30 students is indeed different from that of the national average, because that was the question that we were dealing with. However, if the mean weight of the students 30 students that we are dealing with is different, not just different, but is lower than the population mean, which is 30.8 kilograms. In this case, we will be applying the one-tailed test, and the z calculated value, however, will not change. The z critical values nonetheless will be changed here. So, if we are talking about the 95% confidence level, now we need to apply the one-tailed test, and hence our z critical value will be plus minus 1.64. This implies the z calculated value is greater than the negative z critical value of minus 1.64. In other words, even here the null hypothesis is to be rejected and the alternate hypothesis, which is x bar is less than mu naught, holds true at 95% confidence level. Now, repeating the same thing for 99% confidence level, we need to, let us quickly go to the t table and see what the z value should be used here. We are using the one-tailed test, and we want to see the 99% significance level or 1% significance level, 99% confidence level. So, our z value is 2.326. When we use this critical value also, we see that the z calculated value of 3.26 is still greater than the negative z critical value. So, even at 99% confidence level, we can state that the null hypothesis is to be rejected, or the alternate hypothesis that x bar value is less than mu naught is upheld. Okay. Now, the situation will change if our presumption that S is not, our presumption that S is tending to sigma does not hold true. In that case, we will be applying the t test and use the appropriate t values. Let us consider the first case, which was at 95% confidence level, S not tending to sigma. In that case, our t calculated would be still minus 3.26, but the t critical value would take into account the confidence level as well as the number of readings in terms of the degrees of freedom. And the degrees of freedom now is 29. So, let us look at the t critical value from the table at 29 degrees of freedom. While we do not have it, what we definitely have it, the t value at 95% confidence level and at 28 degrees of freedom. So, we can extrapolate this number to 2.04, and what we observe is that the t calculated is again greater than the T critical. So, at 95% confidence level, our H naught is rejected and the alternate hypothesis holds true. Okay. Even if we do the same exercise at 99% confidence level, I will just give you the T critical value in that case. So, how you write T critical for 99% confidence level and degrees of freedom is equal to 29. We will go back to the table and we are looking at the 99% confidence level and around this will be the reading. Let us presume that this reading is 2.46. Okay. Even if we extend it to 99.9% confidence level and degrees of freedom is equal to 29, the T critical value will be 3.4 now. While our T calculated to recollect was minus 3.26. So, at 99.9% confidence level, we cannot reject the null hypothesis, or in other words, the null hypothesis is to be accepted. So, I hope with this example you understood how T critical and Z critical values are to be found and how you can utilize the T test or the Z test to tell whether a reading is different from a population mean, and not just different, whether it is greater than or lower than the population mean at a certain confidence level.